Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will differentiate y equals sine x. But before we get to that, we need to use this table here and come up with a couple of limits. So here, what I've done is I've just chosen different values for h. You can see h is getting closer and closer to 0. And I've substituted each of these h values into this formula, sine h over h, and also this formula cos h minus 1 over h. So remember, this little symbol here means radians. It's important that when we're differentiating trig functions, our calculations are always in radians. Otherwise, these limits that I'm about to show you won't quite work. So let's look first at this column here. So what's happening is h is getting closer to 0. You can see sine h over h is getting closer and closer to 1. So another way to say this is the limit as h approaches 0 of sine h over h is equal to 1. Again, this rule only works when h is in radians. So we didn't need to do any complicated maths to figure this out. All I did was I just substituted values of h over and over again and made them closer and closer to 0. So h is getting closer and closer to 0. This thing that I put on my calculator is getting closer and closer to 1. And similarly, we see that as h is getting closer and closer to 0, cos h minus 1 over h is getting closer and closer to 0 also. And that's this formula here. Again, h needs to be in radians. And we will need these two formula when we go to differentiate sine x. So the way we're going to differentiate y equals sine x is by using this formula here, which is first principles. All rules for derivatives come from that formula. And I'm going to use these two limits that I figured out on the previous slide. So let's let fx equal sine x. So what would be f of x plus h? Well, all I do is take my formula and replace the x with an x plus h. But we looked at these formula last year. See, this can be expanded using the double angle formula. This is actually equal to sine x cos h plus the opposite, sine h cos x. So that's what we just learned last year. Now what I'm going to do is substitute this, which is f of x plus h, into this formula up here. So we have f dash x equals the limit as h approaches 0 of f of x plus h, that's sine of x plus h, minus f of x over h. Now note that this first term here and this term here both have a common factor of sine x. So I can factorize this term and this term. So if I expand sine x of this, I get sine x cos h minus sine x. So I've just put this term and this term together, and then I've put the other term over here. So to evaluate this limit, I can split this up into this plus this. I can split the limit up into two fractions and then take the limit of this fraction, take the limit of this fraction, and then add them together. So to take the limit of this fraction here, I need this rule here. Again, remember we figured this out on a previous slide. We didn't use any complicated maths. We just put in different values of h that get closer and closer to 0. So this part here, as h gets closer and closer to 0, this thing here approaches 0. Similarly, if we look at this second fraction here, we note the limit as h approaches 0 of sine h over h approaches 1. So this thing in here approaches 1. So note, as h approaches 0, that has no effect on sine x or cos x. This has nothing to do with h. This has nothing to do with h. So what we end up with, as h approaches 0, we get sine x times 0, because this approaches 0. And then as we take the limit as this goes to 0, well, this is just 1 times cos x. And so, of course, sine x times 0 is just 0. And so we're left with just cos x. This simplifies down a lot. The derivative of sine x is actually cos x. So that means the gradient of the curve of sine x, how quickly it's changing, is the value of cos at that point. So how quickly the curve is changing at, sine of 0 is cos of 0. So to differentiate Fx equals cos x, we follow a similar procedure and we still use these two limits and use first principles. But I'll leave that as an exercise. It turns out the derivative of cos x is minus sine x. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.